Welcome to the Military Power Channel. Have you ever wondered what lurks in the sky, beyond the usual commercial flights? There, a secret world exists, a world of ghosts in the atmosphere. They are not UFOs. They are meticulously concealed aircraft, machines designed to spark curiosity and push the boundaries of American aviation technology. Facing north, Edwards Air Force Base stands tall, where the latest war machines are put to the test and pilots are trained. Not far from there, the US Navy base at China Lake quietly develops weapons and electronic systems for the formidable naval forces. But perhaps the most mysterious of all is the Groom Lake area, the epicenter of conspiracy theories about UFOs and extraterrestrials. Rumors of secret activities and advanced technology experiments only add to the strange allure of the Valley of the Deer. Among the rumored secret aircraft, the TR-3A Black Manta has emerged as a symbol of advancement and mystery. Believed to be a supersonic reconnaissance plane, the TR-3A is said to be a collaborative product of the US Air Force and Northrop, the company that created the legendary stealth bomber, the B-2 Spirit. Some reports suggest that this aircraft can reach supersonic speeds and operate at very high altitudes, allowing it to gather intelligence worldwide without being detected. However, what makes the TR-3A truly special is not just its stealth capabilities and speed. Some rumors suggest that this aircraft utilizes a peculiar engine system based on plasma technology and nuclear energy, allowing it to generate a gravity-defying field, reducing weight and increasing speed. Despite numerous rumors and speculations, the existence of the TR-3A Black Manta has yet to be officially confirmed. However, these rumors have heightened public curiosity and interest in the world of secret aircraft. The TR-3A Black Manta, if it truly exists, is said to feature a unique black triangular design covered by a special cloak to render it invisible to radar detection. We have observed similar angular shapes on confirmed ghosts like the B-2 Spirit and F-117 Nighthawk. These shapes are intentionally designed to deflect radar waves, making the aircraft harder to detect. With the TR-3A, the black triangular shape could be the next step, a radical optimization for stealth capabilities. Like the SR-71 Blackbird and the B-2, it likely employs radar-absorbent material, RAM, to swallow radar waves and features a special surface design, making it a true black shadow in the sky. In addition, the TR-3A is equipped with advanced electronic systems that allow it to alter its radar signature, disguising itself as other objects to deceive adversaries. However, what truly makes the TR-3A mysterious are the rumors surrounding its engine system. There are two main theories, each pushing our imagination to its limits. The first hypothesis, based on known aviation technologies, suggests that the TR-3A could achieve supersonic speeds and operate at high altitudes due to significant advancements in conventional engines. The SR-71 Blackbird, despite being developed during the Cold War, has demonstrated that reaching speeds of over Mach 3 and flying at altitudes above 82,000 feet is entirely feasible. To surpass the legendary Blackbird, the TR-3A may need to utilize a ramjet or scramjet engine to reach speeds of Mach 5 to 6 and fly close to the edge of the stratosphere. NASA and DARPA have previously tested scramjets on the X-43A, reaching speeds of Mach 12. If the TR-3A does exist, this technology may have been secretly applied for military purposes. However, the second hypothesis goes further, venturing into the realm of science fiction. Some sources claim that the TR-3A utilizes an engine system based on plasma technology and nuclear energy. This system is said to have the ability to generate a gravity-defying field, reducing the weight of the aircraft and allowing it to move at speeds far beyond anything we have ever known. If this hypothesis is true, the TR-3A Black Manta is not just an aircraft. It represents a leap into the future of aviation technology, a testament to the untapped potential that we have yet to fully explore. One of the most intriguing rumors about the TR-3A Black Manta is its ability to defy gravity. According to those who believe in the existence of this aircraft, the TR-3A can fly without adhering to conventional physical laws, hovering in the air and moving at astonishing speeds. The ability to defy gravity is often understood as a means to neutralize or control gravitational force, allowing it to hover, accelerate suddenly, or change direction without being affected by inertia or air resistance. This goes beyond conventional aviation technology, which relies on aerodynamic lift and thrust from engines. Based on current understanding, overcoming gravity requires a breakthrough in physical theory, such as manipulating gravitational fields or utilizing dark energy. These rumors stem from reports of UFO sightings, where witnesses describe triangular flying objects moving at speeds and with capabilities that no known aircraft can achieve. Some people believe that these objects are actually the TR-3A Black Manta, which is currently being tested and developed in secret. In the early 1990s, many people in Belgium reported seeing a triangular flying object with 4 bright lights in the sky. This object was described as moving with a speed and maneuverability that no known aircraft could match. Some believe that the object was actually the TR-3A Black Manta conducting a test flight. Some people believe in a much more controversial theory, that the TR-3A is the result of efforts to reverse engineer technology from alien spacecraft that have crashed on Earth. This idea, which has deeply embedded itself in popular culture, especially regarding the secrets supposedly hidden at Area 51, suggests that the US government has secretly gained access to advanced alien technology and is attempting to replicate it for military purposes. These rumors often associate the TR-3A with black projects like Aurora, or even the legendary TR-3B variant, a machine believed to use a mercury reactor to create an anti-gravity field, defying all conventional laws of physics. There are even rumors that the TR-3A Black Manta was used in the Gulf War to provide laser targeting for the F-117 Nighthawk bombers, helping them strike their targets with precision. However, it is important to emphasize that all of these rumors have not been officially confirmed. The existence and capabilities of the TR-3A Black Manta remain a mystery. Some experts believe that the TR-3A Black Manta is linked to the development of the B-2 Spirit stealth bomber. According to these individuals, the TR-3A was used as a test platform to develop advanced stealth and aerodynamic technologies, which were later integrated into the B-2 Spirit. The B-2 Spirit is one of the most expensive and advanced bombers in the world. This aircraft has stealth capabilities that allow it to penetrate enemy airspace undetected. Additionally, the B-2 Spirit can carry a significant payload of weapons, including nuclear bombs. If the TR-3A Black Manta truly served as a stepping stone for the development of the B-2 Spirit, it highlights the significance of secret aircraft projects in advancing aviation technology. In addition, the TR-3A is rumored to possess many other advanced technologies, including high-powered combat lasers, weather control capabilities, and extraterrestrial technology gathered from UFO events. However, these rumors remain unproven and should be approached with caution. When we switch to the TR-3B, the story becomes more complex and strange. The TR-3B, also known as Astra, is another type of secret aircraft believed to be related to the TR-3A. While the TR-3A is often described as a supersonic reconnaissance aircraft with stealth design, features that, although advanced, can still be speculated upon based on publicly available projects, the TR-3B takes it to a whole new level, possessing capabilities that far exceed any limits we are familiar with. This very difference has led many to speculate that the TR-3B could be an upgraded version, or even a completely mysterious parallel project of the TR-3A, although there is no official documentation to confirm the existence of either. This engine system is said to have the ability to generate a powerful anti-gravity field, allowing the TR-3B to fly at speeds and capabilities that no known aircraft can achieve. Additionally, the TR-3B is rumored to have the ability to maneuver in space. However, it is important to emphasize that the rumors about the TR-3B are even stranger and more unbelievable than those surrounding the TR-3A. The existence and capabilities of the TR-3B have yet to be confirmed and should be approached with caution. Some people believe that the advanced technologies purportedly found in the TR-3A and TR-3B are linked to Operation Paperclip, a secret US program following World War II. As part of Operation Paperclip, the United States recruited thousands of German scientists and engineers, many of whom had worked for the Nazi regime during the war. Operation Paperclip, 1945 to 1959, was an effort by the United States to recruit German scientists, engineers, and technical experts after World War II, including those who had previously worked for the Nazi regime. The most prominent figure was Wernher von Braun, who led the V-2 rocket program, and later became the chief architect of the Apollo program. In total, over 1,600 German experts were brought to the United States, bringing with them knowledge of rockets, jet engines, and other advanced technologies. These scientists brought with them advanced knowledge and technology, helping the United States excel in the arms race against the Soviet Union. For example, the Me-262 jet engine and the V-2 rocket laid the groundwork for projects such as the X-1 aircraft, which broke the sound barrier, and the US ICBM program. Some people believe that the technologies developed by German scientists during wartime, such as jet engines and rockets, were used to develop the TR-3A and TR-3B. Additionally, the term Wunderwaffe, used by the Nazis to describe their advanced weaponry, is often referenced in discussions about the TR-3A and TR-3B. Some believe that the Wunderwaffe technologies that were not fully developed during the war were further researched and developed by the United States after the war. One of the most recent developments related to the world of secret aircraft is the US Navy submitting a series of strange patents that describe advanced technologies such as gravity wave generators and weapons that manipulate space-time. These patents are associated with Dr. Salvatore Pais, a scientist with an impressive background who has worked for NASA, Northrop Grumman, and the Department of the Navy. The technologies described in these patents are believed to have the potential to revolutionize military technology, providing the United States with a significant advantage over potential adversaries. However, the US Navy's public disclosure of these patents has sparked considerable controversy. Some believe this is a strategy to mislead adversaries, while others think it is a sign that the United States truly possesses these advanced technologies. It is unusual for the US Navy to publicly disclose patents for strange technologies. Typically, military inventions are kept secret to protect national interests. So why did the US Navy decide to make these technologies public? Some people believe that making these patents public is a strategy to mislead the opponent. By revealing advanced technologies, the United States could make the adversary think they have surpassed the US in military technology, thereby causing them to reduce their research and development efforts. In addition, the public disclosure of these patents could also serve as a way to demonstrate the strength of the United States. By showcasing their ownership of advanced technologies, the US can deter potential adversaries and maintain its superpower status. In the world of secret aircraft, one cannot overlook the F-117 Nighthawk, the world's first stealth fighter jet. The F-117 Nighthawk was developed in secrecy during the 1970s and officially entered service in 1983. The F-117 Nighthawk was developed in the 1970s by Lockheed Skunk Works, a division renowned for its black projects such as the U-2 and SR-71. This program, codenamed Have Blue, was kept completely secret until its official announcement in 1988, despite having been operational since 1983. The development of the F-117 occurred during the Cold War, when the United States needed a strategic advantage to penetrate the dense air defense systems of the Soviet Union. This demonstrates America's capability to undertake highly classified projects with breakthrough technology, a factor that could apply to theories regarding the TR-3A and TR-3B. The F-117 Nighthawk features a unique design. with flat surfaces and sharp angles that enable it to evade radar detection. This aircraft has participated in numerous military conflicts, demonstrating the effectiveness of stealth technology. The F-117 was first used in Operation Just Cause, Panama, 1989, and gained prominence during the Gulf War, 1991, where it carried out precision strikes on heavily protected targets without being detected. However, the secrecy surrounding the F-117 Nighthawk has led to many rumors and legends. One of the most famous legends is about the F-19, a stealth fighter that does not actually exist. The F-19 emerged from a simple logic. American fighter jets are usually numbered sequentially: F-14, F-15, F-16, F-18, but there is no official F-19. This gap led many to believe that it was skipped over due to a secret project. The F-19 was envisioned as a stealth aircraft with more aerodynamic lines than the F-117, potentially resembling the shape of the B-2 Spirit or modern designs like the F-22 Raptor. This contrasts with the F-117, which sacrificed speed and maneuverability to prioritize stealth. However, the existence of the F-19 has never been confirmed. In 1999, an F-117 Nighthawk was shot down in Serbia during NATO's Allied Force operation. This incident captured the attention of military experts worldwide, particularly in China. After the accident, Chinese officials reached out to the Serbian government to request access to the accident site. China's aim was to collect debris from the F-117 Nighthawk to study the aircraft's stealth technology. Some sources suggest that China has successfully collected several important pieces of debris from the F-117 Nighthawk, and this debris has aided China in developing its own stealth technology. In addition to various types of fighter jets and secret reconnaissance aircraft, there is a stealth unmanned aerial vehicle known as the RQ-170 Sentinel, also referred to by its nickname, Beast of Kandahar. The RQ-170 Sentinel is a stealth drone developed by Lockheed Martin. This drone is used for gathering intelligence in high-risk areas. The RQ-170 features a flying wing design, similar to the B-2 Spirit, which helps reduce its radar cross-section (RCS). Without a vertical tail or protruding surfaces, it optimizes stealth capabilities against radar detection. This drone has participated in many covert missions, including the attack on Osama bin Laden's hideout in Pakistan in 2011. The RQ-170 Sentinel played a crucial role in the operation to eliminate Osama bin Laden in 2011. This drone was used to monitor bin Laden's hideout and provide intelligence to the US Navy SEALs. However, in 2011, an RQ-170 Sentinel was captured by Iran after it violated the country's airspace. Iran claimed that they were able to intercept and bring down the drone using electronic warfare measures. This incident has sparked a diplomatic crisis between the United States and Iran and has raised concerns about the security of stealth drones. In the secretive world of military aviation projects, Bird of Prey has emerged as a fascinating case study. Developed by Boeing in the 1990s, this is not a combat weapon, but rather a test platform aimed at exploring new frontiers in stealth technology and seeking more cost-effective manufacturing methods. Bird of Prey features a distinctive design, breaking away from conventional molds. With a single, gracefully curved wing and a uniquely contoured fuselage, it is optimized to evade radar detection and air defense systems. This unique shape helps minimize radar cross-section, while the curved body acts as a shield, dispersing radar waves and significantly reducing the likelihood of detection. In addition to its exterior shape, the Bird of Prey is equipped with advanced radar-absorbing materials and other stealth technologies, making it a ghost on radar screens. Interestingly, this project has leveraged the power of computer-aided design, (KD), to develop prototypes, allowing Boeing engineers to design, simulate, and test components quickly and efficiently, thereby minimizing production costs and accelerating the development timeline. With a production cost of only about $67 million, the Bird of Prey is one of the cheapest stealth aircraft ever built. This project has demonstrated that it is possible to create a stealth aircraft at a significantly lower cost than existing stealth planes, opening up new opportunities for the development of stealth technology in the future. Aurora is another secret aircraft project, rumored to be a supersonic spy plane capable of reaching speeds of Mach 5 or higher. Aurora is believed to have been developed in the 1980s to replace the SR-71 Blackbird reconnaissance aircraft. However, the existence of Aurora has never been officially confirmed. Rumors about the Aurora project began to surface in the 1980s, a crucial period during the Cold War when the United States was striving to maintain its reconnaissance advantage over the Soviet Union. This coincided with the retirement of the SR-71 Blackbird, a symbol of supersonic reconnaissance capabilities, from active service in 1990, although it briefly returned to service afterward. From a strategic standpoint, the idea of replacing the SR-71 makes complete sense. While the SR-71 is an advanced machine, it has become too expensive to operate and vulnerable to increasingly modern air defense systems. Therefore, if Aurora truly exists, it would represent a logical advancement, an effort to maintain global reconnaissance capabilities without bearing the costs and risks associated with the SR-71. Some people believe that Aurora was developed and deployed in secret, while others think that the project was cancelled due to excessive costs and technical challenges. Despite numerous rumors and speculations, the existence of Aurora has not been officially confirmed. The US government has repeatedly denied the existence of this project, and there is no credible evidence to prove that Aurora has been developed and deployed. However, some people believe there is indirect evidence for the existence of Aurora. For example, several witnesses have reported seeing triangular-shaped aircraft moving at extremely high speeds in the sky, and these aircraft could be Aurora. In addition, some experts believe that technology has advanced to the point where it is possible to create a supersonic aircraft like the Aurora, and that the United States may be secretly developing such a plane. The world of secret aircraft is a realm filled with mystery and intrigue, where advanced technologies and thrilling rumors intertwine. From the legendary TR-3A Black Manta to enigmatic projects like Aurora and stealth drones operating in the shadows, this world has captured the attention of experts, aviation enthusiasts, and the general public alike. Although many details about these secret aircraft remain undisclosed, what we do know is enough to show that aviation technology is advancing at a rapid pace, and the future of the aviation industry holds many surprises. Are you intrigued by these secrets? Do you want to learn more about these amazing aircraft?
You won't believe the shocking secret that has just been revealed, sending shockwaves through the aviation world. The United States has successfully tested an advanced hypersonic weapon that surpasses the legendary SR-72 Dark Star, leaving military experts and rivals in awe. How can an aircraft reach the insane speed of Mach 10? Join Navy Power as we explore the surprising details and groundbreaking technology behind this experiment in today's video. Although supersonic technology is regarded as a breakthrough of the 21st century, few people know that it originated during the Cold War, when the United States and the Soviet Union engaged in a fierce race to dominate the skies and space. For many years, this technology was neglected in secret military laboratories due to budget constraints and a lack of practical applications. However, now, as global tensions rise and the arms race reignites, world powers are pouring resources into developing hypersonic systems, weapons capable of surpassing missile defense shields and striking with unprecedented speed and accuracy. The journey to conquer supersonic speed began in 1959 with North America's X-15 rocket plane, a pioneering prototype that still holds the record for a manned aircraft at Mach 6.7. Launched from a B-52 bomber, the X-15 demonstrated that supersonic flight was possible, but its rocket engine consumed fuel too quickly, making it nearly impossible to maintain speed for extended periods. Despite facing countless challenges, the supersonic dream has never faded. Engineers have begun researching scramjet engines, which have the capability to maintain supersonic speeds without the need for bulky rocket fuel. However, barriers such as extreme temperatures at speeds exceeding Mach 5 and the need for advanced thermal protection systems have slowed development progress. Imagine this: building an aircraft where 90% of its weight is fuel. It sounds absurd, but that is the challenge engineers had to tackle in the early stages. What do you think about this advancement and the challenges facing the military industry? Will we soon witness a revolution in the skies in the coming years? Please share your thoughts. Imagine a world where you can fly from New York to Tokyo in under 2 hours, a dream that is about to become a reality thanks to advanced supersonic engines like ramjets and scramjets. Unlike rocket-powered aircraft that must carry large amounts of fuel and oxidizer, these engines use the surrounding air to generate thrust during flight. This not only enhances efficiency, but also marks a significant breakthrough in the aviation industry. To understand the effectiveness of these engines, let's discuss an important metric: specific impulse, which measures the thrust produced relative to the amount of fuel consumed. Traditional rocket engines achieve about 450 seconds of specific impulse, but ramjets and scramjets can exceed 1,000 seconds. This means that aircraft can fly farther, save fuel, reduce costs, and be more environmentally friendly. However, not all jet engines are the same. Turbojets, commonly found on fighter jets, excel at low speeds and can reach speeds of up to Mach 2. However, beyond this threshold, they become less efficient. A ramjet, on the other hand, is designed for high speeds, but requires an initial thrust, making takeoff a challenge. Then we have the scramjet, a true beast that operates at speeds above Mach 5, opening up the potential to revolutionize commercial aviation. But there is still one issue. These supersonic engines perform poorly at low speeds, making takeoff and landing a challenging task. This is also why many supersonic vehicles today cannot be reused as expected. A potential solution to the takeoff and landing issue is to develop a hybrid engine system that integrates both turbojet and scramjet technologies into a single design. In the UK, engineers at Reaction Engines are at the forefront of developing the Sabre, synergetic air-breathing rocket engine, a groundbreaking technology with the ability to seamlessly switch between two operating modes. At low speeds, the Sabre operates like an air-breathing jet engine, using oxygen from the atmosphere to burn fuel, which helps save on the amount of fuel carried. When reaching high speeds or great altitudes, the engine switches to rocket mode, using stored oxygen in the chamber to maintain thrust in thin air or in outer space. This technology not only addresses the technical limitations of traditional propulsion systems, but also promises to significantly reduce operating costs, opening up the potential for more frequent space missions. In the field of military aviation technology, a bold idea is stirring excitement. Why not combine turbojet and ramjet engines into a unified system? This is the groundbreaking vision that Hermeus has realized with the Chimera engine. The name Chimera is not a coincidence. In Greek mythology, the Chimera is a mythical creature that combines elements of a lion, a goat, and a serpent. Similarly, The Chimera engine is a unique fusion of turbojet and ramjet technology, representing a significant advancement. This engine utilizes a combined cycle mechanism based on a turbine, TBCC, allowing for a smooth transition from turbojet mode to ramjet mode. As a result, Hermeus's quarter-horse aircraft can take off like a conventional airplane and then accelerate to supersonic speeds without any hindrance. However, the biggest challenge at hypersonic speeds is the extremely high temperatures. The engineers at Hermeus have tackled this issue by designing the quarter-horse with exceptional heat resistance, preventing overheating in mid-air, a feat in the technology of reusable hypersonic aircraft that was once considered impossible. The standout feature of the Chimera engine is its precooler, which functions like a state-of-the-art air conditioner, lowering the temperature of the air before it enters the turbojet. This technology may sound simple, but it is crucial for optimizing engine performance, especially when transitioning to ramjet mode at speeds above Mach 5. However, this speed not only ushers in a new era for the military, but also represents a strategic goal for the Pentagon, which is heavily investing in combined cycle engines to achieve extreme velocities. Incredibly, Hermeus completed the Chimera engine in just 21 months at a cost of $18 million, a modest figure compared to the U.S. Air Force's hypersonic project, which has exceeded $300 million and spanned several years. With creativity and efficiency, the aerospace industry is witnessing remarkable advancements. As Hermeus embarks on developing a combined cycle engine for the Chimera project, they have opted not for a new engine, but instead placed their trust in the General Electric J85 turbojet, a venerable veteran. This engine has proven its reliability over decades, having been the heart of military aircraft such as the Northrop F-5 Freedom Fighter and the T-38 Talon, and it is still in use today. The J-85 stands out not only for its durability, but also for its exceptional performance in tasks ranging from combat to training. But Hermeus doesn't stop there. Just 1 year after launching the first version of Chimera, they began developing Chimera 2, a more powerful variant. While aerospace giants often take years, even decades, to upgrade their engines, Hermeus's pace of innovation is truly remarkable. This time, they collaborated with the Pratt & Whitney F-100 engine, a veteran warrior that has powered two legendary American fighter jets, the F-15 Eagle and the F-16 Fighting Falcon. With 50 years of service and over 30,000 flight hours, the F-100 has proven its reliability through the most demanding missions, from combat to global patrol. The design of the Chimera 2 engine is a remarkable engineering feat, integrating the Pratt & Whitney F-100 core with a ramjet system in a sophisticated combined cycle design, TBCC. The highlight is the improved precooler, which uses ultra-thin heat pipes to reduce the temperature of compressed air from 1,000 Lutz to a safe level for the turbine in an instant. This system, combined with an intelligent airflow control valve, allows the Chimera 2 to seamlessly switch between turbojet mode at low speeds and ramjet mode at supersonic speeds, ensuring optimal performance across all speed ranges. This design not only reduces the engine's weight, but also increases its durability, enabling the aircraft to operate continuously in harsh conditions. Advanced ceramic composite materials are used in heat-resistant components, enhancing wear resistance and maintaining performance at extremely high temperatures. Furthermore, the Full Authority Digital Engine Control, a FADEC system, optimizes the fuel combustion process, reduces energy consumption, and improves reliability. Hermeus's project is not just an engine upgrade. It represents a leap forward in aviation technology. The supersonic quarter-horse aircraft is not a conventional improved version, but a true dark horse designed to conquer speeds exceeding Mach 5, 5 times the speed of sound. To achieve this speed, the aircraft must contend with extremely high temperatures caused by air friction. The Hermeus engineering team is working diligently to develop a fuselage that can withstand these harsh conditions, ensuring safety and performance at supersonic speeds. The strength of the quarter horse lies in its ability to reach speeds exceeding 3,800 mph, Mach 5+, far surpassing modern military aircraft like the F-22 Raptor, Mach 2.25. The aircraft's body is constructed from a titanium alloy and carbon ceramic composite, resulting in a structure that is both lightweight and capable of withstanding temperatures up to 3,100 °C. The active cooling system, utilizing a circulating fluid, helps maintain a stable temperature for critical components such as the wings and nose of the aircraft. With a payload capacity twice that of the SR-71 Blackbird, the quarter horse is not only fast but also versatile, capable of carrying weapons, sensors, or passengers, unlocking potential for both military and commercial applications. The advanced avionics system, integrated with AI, enables real-time data processing, optimizes flight paths, and responds quickly to threats. Additionally, the improved aerodynamic design reduces drag, allowing the quarter horse to maintain exceptional performance at supersonic speeds. Hermeus is racing into the supersonic era, pioneering technology that is set to ignite the imagination and promises to turn the sky into a speed highway. Are you excited about the day when supersonic planes will take you around the world in the blink of an eye? Share your thoughts in the comments below this video. How crazy do you think the future of aviation will be? Don't hesitate. Comment now to join the discussion. Hermeus aims to surpass the legend of the Lockheed SR-71 Blackbird, the fastest manned aircraft in the world, with a speed of Mach 3.3. However, Hermeus's ambitions go beyond speed. They also aim to conquer the edge of the stratosphere at an altitude of 80,000 to 85,000 feet, twice that of commercial airplanes, 35,000 to 40,000 feet. At this altitude, the air is extremely thin, making it difficult for the jet engine to draw in enough oxygen. The wings generate less lift, and the temperature fluctuates drastically from scorching hot to freezing cold. To give you an idea, the SR-71 Blackbird once flew at 85,000 feet to evade enemy missiles and radar, with pilots required to wear pressure suits like astronauts because low pressure can be life-threatening. Hermeus not only aims to fly faster, but also more efficiently, tackling some of the greatest technical challenges in aviation history. Flying at supersonic speeds, over Mach 10, 5, generates tremendous friction and heat, which can reach up to 2,000 trillion, enough to melt aluminum and weaken titanium. To overcome this challenge, Hermeus engineers are developing heat-resistant alloys, ceramic materials, and advanced cooling systems to ensure the aircraft can withstand extreme conditions. Traditional jet engines cannot achieve supersonic speeds, so Hermeus is betting on scramjet technology. This type of engine compresses air at incredible speeds without the need for a spinning turbine, unlocking the potential for efficient supersonic flight. At Mach 5, the aircraft reaches speeds of over 3,800 mph, causing the surrounding air to heat up to levels that ordinary materials cannot withstand. Therefore, engineers are using super-durable materials such as titanium alloys, nickel alloys, and superalloys, similar to those used in spacecraft. What do you think about this leap forward in aviation technology? Will Hermeus's supersonic aircraft shape the future of transportation or aerial warfare? Please share your thoughts. To cope with the extreme temperatures ranging from 1,000 degrees to over 2,000 degrees when exceeding Mach 6, Hermeus is facing unprecedented challenges. Some experts believe that while nickel alloys are durable, they are too heavy for a supersonic aircraft that requires both speed and efficiency. Hermeus's solution is to use carbon ceramic composites, an advanced material that is not only lightweight, but also offers superior heat and pressure resistance compared to traditional metals. With a heat resistance of up to 3,100 degrees for reusable components and 3,600 degrees for single-use applications, this material is being utilized in advanced aerospace projects such as hypersonic rockets and space shuttles, ushering in a new era for ultra-durable and ultra-fast aircraft. Composite carbon ceramic has proven its strength in the aerospace and automotive industries, particularly in components like brake discs, thanks to its ability to maintain structural integrity at extremely high temperatures. However, Hermeus not only selects materials, but also innovates the manufacturing process. They have invested in Velo 3D Sapphire and Sapphire XC industrial 3D printers, which enable the production of complex parts with high precision and speed. In particular, these printers utilize Inconel 718, a nickel-chromium alloy renowned for its heat resistance ranging from 423 degrees to 0.1300 degrees, as well as its corrosion resistance and ability to maintain strength in demanding applications such as gas turbines and aerospace components. 3D printing technology not only allows Hermeus to create parts with unique shapes that traditional methods cannot achieve, but it also reduces costs and increases production efficiency. The Chimera engine and the quarter-horse aircraft, though they look like they stepped out of a science fiction movie, are built on the most advanced engineering foundations. These innovations not only enhance performance, but also lay the groundwork for safer and more sustainable supersonic vehicles. What do you think about these advancements? Do you believe the current technological challenges will lead to a revolution in aerospace, resulting in faster and safer airplanes? Please share your thoughts and predictions. Hermeus's quarter horse, with its airframe primarily made of titanium, a metal renowned for its high strength and lightweight properties, symbolizes the fusion of power and efficiency. Its sharp, sleek design is not only visually striking, but also represents a breakthrough in aerodynamics. The razor-sharp lines are perfectly integrated into the aircraft's body, creating a seamless appearance that is both captivating and optimized for performance. Reminiscent of the legendary Lockheed SR-71 Blackbird, the quarter horse is designed to glide through the air with minimal drag, making it ideal for high-speed missions. To achieve outstanding performance at hypersonic speeds, Hermeus has pioneered the use of advanced composite materials combined with titanium alloys, a breakthrough that has not been documented in any previous literature or reports. These materials are specially designed to withstand extremely high temperatures generated when an aircraft reaches speeds of Mach 2.5 or higher, while also minimizing wear and tear under the most severe operating conditions. Hermeus is also at the forefront of integrating advanced metal 3D printing technology into the manufacturing process of complex components, significantly reducing production time from several months to just a few weeks, while still ensuring near-absolute precision at the microscopic level. This innovation not only enhances the durability and performance of the quarter-horse aircraft line, but also opens up groundbreaking prospects for the mass production of supersonic aircraft at more optimal costs. Measuring 40 feet long, the quarter horse is slightly smaller than the Northrop T-38 Talon, which is 46 feet in length, but both share many similarities. Designed for advanced training and light attack, the T-38 has been one of the most successful training aircraft since the 1960s, training thousands of military pilots. However, the quarter horse is currently just a prototype. During the test flights, real data will lead to adjustments aimed at optimizing performance, stability, and safety at supersonic speeds and high altitudes. Last year, Hermeus made significant progress with the quarter-horse Mk0, completing its assembly in just 6 months. A remarkable achievement given the complexity of the technology involved. In the experiment, Mk0 not only met, but also exceeded all objectives, demonstrating its exceptional potential. This success has attracted the attention of the U.S. Air Force, paving the way for extensive collaboration. An important aspect that has not been mentioned is the integration of artificial intelligence, AI, into the control system of the quarter horse. Hermeus has developed advanced AI algorithms to assist pilots and automated systems, enabling aircraft to handle complex situations in real time, such as adjusting their trajectory when encountering atmospheric turbulence or automatically switching between flight modes, from turbine to ramjet. AI not only enhances safety, but also reduces the workload for pilots, especially during high-speed missions that require immediate responses. This technology has the potential to reshape pilot training, as AI systems act as intelligent co-pilots, providing support in both combat and training scenarios. Hermeus's quarter horse is not only a breakthrough in training, but also a potential combat machine, pushing the boundaries of modern military aviation. In just 37 days, the team at the Arnold Engineering Development Complex, AEDC, in Tullahoma, Tennessee, conducted groundbreaking tests that opened the door to the future of aviation. These tests not only evaluated new technologies, but also shaped how next-generation military aircraft will operate. A major challenge is studying the human factors, how pilots interact with advanced control systems. Researchers have simulated scenarios of losing connection with the ground, which aids in designing effective emergency procedures. In addition, they also check the radio frequency latency to ensure that the communication system operates smoothly without compromising safety or performance. Remote control testing has also been intensified to ensure that the aircraft can operate safely even without a pilot on board. At the beginning of 2024, the quarter-horse Mk0 completed its testing, becoming the first prototype in 4 versions of the quarter-horse program, marking a historic milestone. By March 2024, the Mk1 prototype will be launched with an ambitious goal: to take off and land automatically. Achieving precision in automated flight is a significant challenge, requiring the team to spend 7 months assembling the Mk1 with each detail perfected. Then, at Edwards Air Force Base in California, known for its advanced aerospace testing, the Mk1 completed all its tests in just 21 days. To achieve optimal accuracy in automated operations, Hermeus has integrated an advanced sensor system into the quarter-horse Mk1, which includes an electronically scanned phased array radar, AESA, and modern LiDAR sensors. These technologies enable aircraft to create high-resolution 3D environmental maps in real time, allowing for timely detection of obstacles and automatic, flexible trajectory adjustments, even in harsh weather conditions such as storms, dense fog, or strong winds. The sensor system not only plays a crucial role in supporting fully automated takeoff and landing procedures, but also significantly enhances the capabilities for monitoring, reconnaissance, and data collection, transforming the quarter-horse Mk1 into a versatile platform with extensive application potential. This technology is designed as a solid foundation, laying the groundwork for the upgraded Mk2 and Mk3 versions, which will require the ability to process more complex data to meet tasks at supersonic speeds while ensuring safety and efficiency in high-intensity operational environments. At Edwards, the Mk1 was pushed to its limits with high-speed taxi tests, reaching 50 mph in full afterburner mode, a remarkable feat for a drone. These tests provided crucial data on stability and control at high speeds, laying the groundwork for future flights. These innovations are not only technological advancements, but also change the way military vehicles operate. Are you excited about the prospect of a future where supersonic aircraft become the norm? Share your thoughts. The Hermeus team is making remarkable progress with the two prototypes, quarter-horse Mk2 and Mk3, while the Mk1 has begun production at the factory in Atlanta, Georgia. This is a significant milestone, especially for the Mk2, as it is equipped with the Pratt & Whitney F100 engine, which is much more powerful and reliable than the GE J85 engine used in the Mk1. The F100, renowned for powering the F-15 and F-16 fighter jets, is key to the Mk2 achieving its ambitious goals. The Mk2 aims to break through sound barriers, achieving supersonic speeds of Mach 2.5 in automated flight mode, a significant leap in aviation. Supersonic flight without a pilot requires advanced systems, from precise navigation to emergency situation handling. The Mk2 is not only fast, but also smart, functioning like an autopilot in the sky. While the detailed specifications remain confidential, the technical challenges that Hermeus is addressing are truly revolutionary. What's even more interesting is that the Mk2 is said to incorporate technology from the Chimera Tuturn. Sutu, an upgraded version of the Chimera engine, which uses the F100 as the turbine core and adds a pre-cooler to achieve higher efficiency. The Mk2 will test the transition from turbine mode to ramjet during flight, a technical feat that requires perfect coordination at maximum speed and altitude. If successful, this will lay the groundwork for the Mk3, which is designed to break the speed record of the SR-71 Blackbird, Mach 3.3, an undefeated icon in high-speed aviation for decades. The Mk3, equipped with the complete Chimera 2 engine, will propel the quarter-horse beyond Mach 5, aiming to become the fastest aircraft in the world. This ambition is not only a dream for engineers, but also a game-changing milestone in both military and civilian aviation. In addition, Hermeus is revolutionizing test management with Flight Deck, a self-sufficient control platform that operates independently without the need for a power grid. Designed for extreme environments, from remote areas to hostile territories, the flight deck ensures comfort and safety for pilots and crew with specialized seating. This platform has been successfully tested on the Mk1, assessing its electromagnetic interference resistance and optimizing remote control capabilities. The quarter-horse is designed with a pioneering vision to deeply integrate into network-centric warfare systems, a trend that is shaping and restructuring modern warfare. The upgraded Mk2 and Mk3 versions will be equipped with the capability to share real-time data with various units, including fighter jets, satellites, naval vessels, and ground command centers, forming a tightly interconnected information network. Thanks to this capability, the quarter-horse not only functions as an independent platform, but also serves as a crucial node in the combat network, providing detailed reconnaissance information, environmental data, and real-time decision-making support for allied forces. This technology not only optimizes combat effectiveness, allowing for seamless coordination among units, but also significantly reduces risks for pilots, especially in dangerous missions or complex combat environments. What do you think about the potential of the Mk2 and Mk3? Could they usher us into a new era of supersonic transportation or aerial warfare? Please share your thoughts. In a world where time is money, a small team of 4 talented operations analysts, along with specialized observers, is working in a state-of-the-art, high-performance computing center. Unlike typical data centers, this facility is designed with absolute precision, incorporating advanced climate control systems to maintain a completely isolated environment. This ensures safety and reliability for critical aviation equipment, even in the most extreme conditions. On the outside, this center looks like an ordinary shipping container, but don't let its simplicity fool you. This design allows for easy transportation and deployment in any location, from remote deserts to war zones, providing unprecedented flexibility. It's not just a data processing facility. It's the key to breakthroughs in the aerospace industry. All these efforts are aimed at an ambitious goal: to develop Halcyon, the supersonic passenger aircraft that promises to completely change the way we think about air travel. With a speed exceeding Mach 5, more than 5 times the speed of sound, Halcyon can operate over 125 transoceanic routes, significantly reducing travel time. Imagine this: a journey from New York to London, which typically takes 7 hours, is now just 90 minutes. The technology behind Halcyon is a marvel of engineering. Hermeus aims to conduct the first test flight of Halcyon in 2029. Prior to that, 2 prototypes, quarter-horse Mk2 and Mk3, will debut in 2025 and 2026, testing core technologies such as the Chimera 2 engine and optimized aerodynamic design. The Mk2, equipped with an upgraded Pratt & Whitney F100 engine, will achieve supersonic speeds exceeding Mach 2.5, while the Mk3 aims to break the speed record of the SR-71 Blackbird, Mach 3.3, laying the groundwork for Halcyon. The most impressive thing is the speed of Hermeus's development. Supersonic flight is a colossal challenge with countless technical barriers, ranging from extremely high temperatures to complex control systems. However, the Hermeus team continuously pushes the limits, taking only 7 months to build the Mk1 and 6 months for the Mk0. Their dedication and creativity are turning what once seemed impossible into reality. There's no doubt that perseverance is driving humanity to new heights in aviation. Hermeus's Halcyon project is not just a technological advancement, it is the key to unlocking an unprecedented era of global connectivity. With the ability to fly at speeds exceeding Mach 5, Halcyon promises to revolutionize air travel, turning long journeys that typically take hours into trips of less than 2 hours. Imagine, from New York to Tokyo, London to Sydney, in the blink of an eye. This not only transforms the aviation industry, but also profoundly impacts the economy, culture, and the way we live. The dream of supersonic travel is gradually becoming a reality, and with the rapid development of Hermeus, that future is closer than ever. Thank you for joining the Navy Power Channel on this exploration journey. Don't miss out. Click on the next video on the screen to discover more groundbreaking advancements. What will the future of supersonic aviation look like? Will Halcyon change the world? Leave your thoughts in the comments below, and let's discuss with Navy Power.